Hello, everyone, and welcome to another virtual lesson. My name is Michael Faribaugh, and I teach AP Chemistry at Albemarle High School in Charlottesville, Virginia. Today is our last lesson in the series, and so what I decided to do for today's lesson is to present you with a variety of free response questions on different topics. And what I will do is I'll present a student answer, and that student answer is incorrect for some reason. I'll give you a moment to process, think about what the student might have done that was incorrect or incomplete, and then I will show you the official answer with the scoring guidelines. In terms of our practice questions today, I have pulled them from the free response questions from the 2019 and the 2018 AP Chemistry free response. Now, these are publicly available, so if you do an internet search for 2019 AP Chemistry free response, then you will definitely find both the questions themselves and the scoring guidelines. Okay, so you can definitely check these out. You don't need to have access to these questions right now, but if you want to look them up later, that's all you have to do. All right, let's dive into our lesson. So you are given in this particular question an equation in which a substance is going from a solid to an aqueous species. This is called urea, and it has the chemical formula H2NCONH2. It gives you the molar mass, and it says a student determines that 5.39 grams of urea can dissolve in water to make 5.00 milliliters of a saturated solution at 20 degrees Celsius. The question is asking, calculate the concentration in moles per liter. Now, again, each of these sample student responses that I'm presenting has a mistake. So be looking for the mistake as well as think about what the correct answer would be. All right, here we go. So I'll give you a moment to see what this student has done correctly and what they have made a mistake with. And again, throughout today's video, feel free to pause if I jump to the answer before you're ready to think about it. Feel free to pause the video and have some time to think and process. All right, so what this student did correctly was they calculated the moles. What they did incorrectly was the volume. So 5.00 milliliters, if you divide that by 1,000 to go from milliliters to liters, that would be 0.005. So my lesson here is be careful that on the AP Chemistry exam, you don't make some careless errors in terms of mathematical calculations. All right, here's the next question, which is related to the last question in which the concentration was supposed to be 17.9 molar at 20 degrees Celsius. It says a student also determines that the concentration of this same chemical, urea, in a saturated solution is 19.8 milliliters at 25 degrees Celsius. So based on this information, is the dissolution or dissolving of urea endothermic or exothermic? Justify your answer in terms of Le Chatelier's principle. Now, even though you know that what I'm about to show you is a student answer that is wrong, I still need you to kind of process what the correct answer would be and distinguish between the student's mistake and how you would solve this problem correctly. All right, here we go. So the student writes, the dissolution of urea is exothermic. A 19.8 molar solution is 25 degrees Celsius, while a 17.9 molar solution is 20 degrees Celsius, meaning that the molarity of urea increases as the temperature of the solution increases. And they go on to say, due to Le Chatelier's principle, as urea proceeds to dissolve or dissolute, it releases heat to the surroundings, so it is exothermic. So what they did correctly is they wrote a very good description of what is happening in terms of the observations. They have the correct concentrations at the different temperatures. But what they did incorrectly is they made the wrong choice. It turns out that when you increase the temperature and a reaction shifts toward the products, as this one did, that is an endothermic process. So they had the right description of what was happening, but they said exothermic instead of endothermic. All right, here we have a different question from the 2019 free response section. All right, we are told that the boiling point of Br2 is 332 Kelvin. whereas the boiling point of BrCl is 278 Kelvin. Explain this difference in boiling point in terms of all the intermolecular forces present between molecules of each substance. So again, think about how you would answer that question. As I mentioned, feel free to pause the video if you want some time to process and think, that's fine. I'm going to show you a student answer that is incorrect. So take a moment to see what they did correctly and or incorrectly. It says the boiling point of Br2 is higher than that of BrCl because of the intermolecular forces. In Br2, there are London dispersion forces. In BrCl, there are weak forces because both Br and Cl already have 7 valence electrons. So think about how you would have phrased your answer to this question a little bit differently, and then I'll reveal the scoring guidelines and what their mistake was. All right, here are the official scoring guidelines. The only intermolecular attractions in Br2 are London forces. So they got that part right. However, they did not state the intermolecular forces in BrCl. They should have mentioned the London dispersion forces and the dipole-dipole forces for BrCl. They also did not state in their answer that the intermolecular forces, or IMFs, in Br2 are stronger than the IMFs in BrCl. So they actually did not earn any points on this question because they were not complete. So again, read the question carefully and make sure that you are answering the question that is being asked. All right, here's our next one. We are given that 2 molecules or 2 moles of BrCl is transformed into 1 mole of Br2 and 1 mole of Cl2. And these are all gaseous species. We are also given that the delta H for this process is 1.6 kilojoules per mole of reaction. Calculate the bond energy of the BrCl bond. So as you can see in the table, we have the bond energy between 2 bromines, between 2 chlorines, but there's a question mark between the bromine and the chlorine. So calculate the bond energy of the BrCl bond in kilojoules per mole using the delta H for the reaction. So 1.6 kilojoules per mole of reaction, and the information in the following table. Okay, here is the student's incorrect response. So again, be thinking about what you would say to answer this question, how you would show your work. And I will now reveal the scoring guidelines and the correct answer. Now, if you just look at the numbers, initially you might think that the student is actually correct because you think, oh, it's close enough, 217.2, oh, 219, that's only off by about 1.8, but there's a small difference between the reactants and the products, and that's the 1.6. So what they have done incorrectly is they have treated this as a products minus reactants, and that is only used for the enthalpy of formation, not for bond energy, a very common misconception. So they have essentially said bonds formed minus bonds broken, which is backwards. Okay, so the 1.6 is correct, but they should have had the 2 times the bond energy of BrCl, which is an endothermic process to break the bond, minus the energy essentially released when the bonds are formed. That's the 193 and the 243. So correct answer, according to the scoring guidelines, is 219, and they did it backwards. Again, common mistake. Just don't fall into that trap on the AP exam. Make sure you understand the difference between delta H of formation and bond energy and how you set that up. All right, in our next problem, it says a student is given 50.0 milliliters of a solution of sodium carbonate, Na2CO3, of unknown concentration. And so in part C, it says determine the number of moles of Na2CO3 in the original 50.0 milliliters of solution. So how do we do that? Well, there was a reaction that took place. The student reacted the sodium carbonate with an excess amount of calcium nitrate, CaNO3 parentheses 2, and a precipitate formed. You can see a precipitate is formed right here on the right side of the equation. and we are given the mass of that precipitate. So our job is to determine the number of moles of sodium carbonate. Let me reveal the student's work. See if you can take some time to think about how you would answer this question and what the student might have done wrong. So there are the conversion factors, and they have a final answer of 0.00465. All right, here is the official scoring guidelines. Well, you can see a similarity between their answer and the correct answer. They definitely went from grams to moles correctly for calcium carbonate. They recognized the 1-to-1 mole ratio, and that's where that student should have stopped. So effectively, they should have stopped right here. I'm sorry, excuse me, right here. So this was the part that they did wrong. Had they stopped, they would have gotten 0.0093, but for some reason they divided by this ratio of volumes, which was incorrect. And so essentially they have an answer that is exactly half of the correct number of moles. Again, the piece of advice I can give you here is watch out for careless errors. In this case, they were possibly trying to use all the numbers in the table in some way, and that wasn't required to get the correct answer. Okay. Here we have the next part of this same question. It says the student realizes that the precipitate, again, that is the precipitate here, was not completely dried and claims that as a result, the calculated sodium carbonate molarity is too low. Do you agree with the student's claim? Justify your answer. Now, again, this is a very common question style on the AP chemistry exam. There is a claim based on experimental evidence, and then you have to decide if you agree or not. So think about whether you agree or disagree, make sure you state that, and then consider the chemistry concepts involved when you justify your answer. This is what the student said. They said, I do agree because molarity is determined on volume. If there is, or if there was, a bit of sodium carbonate liquid left on the precipitate, it would affect the molarity because molarity is found by taking moles over liters. So they're saying that the volume is too high and the molarity is too low. All right, and here's the official scoring guidelines answer. Okay, you have to be careful here. This substance, we can definitely convert from grams of calcium carbonate into moles of sodium carbonate. But then we would be dividing by the volume of the solution to get the molarity. So if this sample of precipitate is wet, then that means that the mass is too high. And that's what it says here in the box. The presence of water in the solid will cause the measured mass of the precipitate to be greater than the actual mass. As a result, the calculated number of moles of calcium carbonate and moles of sodium carbonate will be greater than the actual moles. So the student is talking about molarity, but you're not going to take the molarity of the precipitate. So we're not talking about extra volume here. We're talking about extra mass that makes this calcium carbonate precipitate too heavy. So again, be careful with your language, think about what the question is asking, and decide how a particular laboratory scenario would affect the data and the calculations. All right, we're still on the same question. This is the next part. After the precipitate forms, so again, we have I'm just going to go ahead and draw a little funnel here. Okay, and we have a flask. So we have the solid would be on the filter paper up here. That's the calcium carbonate. And then here we have a solution that would contain the ions. Okay. After the precipitate forms and is filtered, the liquid that passed through the filter is tested to see if it can conduct electricity. And the student says, again, what would be observed? Justify your answer. Electricity would be observed, as in it would conduct electricity. because the experiment is testing for an ionic compound, and calcium carbonate is an ionic. Calcium and carbonate are ions that need each other's valence shells. This is an ionic bond. So they're saying, yes, it's a conductor because calcium carbonate is ionic. So think about what their mistake was and what you would say. And the correct answer, according to the scoring guidelines, is it is going to conduct electricity, but not for the reason that they said. It's because the ions, the sodium ions, the excess calcium ions that are present in aqueous environment, and the aqueous nitrate ions, that's what's present. So the problem with their answer is they're talking about a precipitate, and that is not in the solution. That was separated and on the filter paper. So calcium carbonate is not in the solution, it is on the filter paper. So they can't talk about calcium carbonate as the reason why it would conduct electricity. I hope all of these examples, and we're going to do a bunch more, are helpful to you to kind of guide you through the process of how you can break down a free response question, focus on the important information, and then again, especially when you have to justify your answer, you can do it in a very clean, straightforward way. All right, here we have a new question. It's talking about a sample of carbon dioxide. It says the sample was at 299 Kelvin, and the student increases the temperature to 425 Kelvin. In terms of kinetic molecular theory, briefly explain why the pressure of the CO2 changes as it is heated. So we didn't actually know if the pressure went up or down. You can think about that, but you have to explain why. I would like your answer to be in terms of particles and collisions. Here's what the student said. The pressure increases when the temperature is raised because gas molecules move faster and collide with each other more when temperature is raised. So there is a mistake here, and it's kind of a subtle mistake. So at first, when you read this question, you might not be able to recognize what the student did incorrectly. But think about your word choice. When you are writing free response questions, make sure you are very clear with your language. Here's the official scoring guidelines. Take a look at the difference between what they said and what they should have said. Faster moving gas particles collide more frequently with the walls of the container, thus increasing the pressure. Or faster moving molecules collide more forcefully with the walls of the container, thus increasing the pressure. So what they did wrong is they said that the particles are colliding with each other instead of with the container walls. So pressure, gas pressure, has to do with collisions between the particles and the container walls. That's a very minor thing you might think, but in fact, it did cost them the point in this particular explanation. So again, be careful with your word choice in terms of understanding the concepts. All right, next example. The student measures the actual pressure of the CO2 in the container at 425 Kelvin and observes that it is less than the pressure predicted by the ideal gas law. Explain this observation. So this has to do with the deviation from ideal behavior, why sometimes the properties of a gas, a real gas, may not be the same as the properties predicted by the ideal gas law. Here's what the student said. The ideal gas law does not account for very high temperatures and thus causes the discrepancy. So think about how you might have phrased your answer to this question differently. Okay, what would cause the pressure observed to be less than that predicted by the ideal gas law? And the official answer is that the attractive forces between the CO2 molecules result in a pressure that is lower than that predicted by the ideal gas law. So this student talks about high temperatures, but is not very specific. And again, a high temperature on its own is not a reason for a gas to deviate from the ideal gas law in terms of behavior. If the pressure is less, it might be because there are fewer or less forceful collisions with the walls of the container because the gas particles experience some level of attractive forces between them. All right, here is our next question, a different one. This has to do with a photoelectron spectrum. Now, we are not told what the element is. It says, write the ground state electron configuration of the element and identify the element. So think about how you would interpret this PES diagram. And if you have access to a periodic table, you can take a look and see which element you think this is. Here is the student's answer. They have written an electron configuration based on this diagram of 1s2, 2s2, 2p6, 3s2, 3p6, 3d2. And they said it was calcium. So think about what mistake they might have made and how you would compose a correct response to this question. If you're looking on your periodic table at the moment, you can see that calcium, in fact, does have 20 electrons. And so we have 20 electrons here, but it's going to be 3p6, 4s2. So they have made a mistake in the final part of their electron configuration. They got the right identity of the element, but they messed up the last part of the electron configuration. So again, watch out for careless errors, especially if you are rushing through your answer to a question. So I do encourage you to focus on the time and be aware of it. However, I don't want you to rush and make some careless errors like this student did. Okay, new question. There's a lot to fit on this slide, so I apologize if it's too much to process. I'll go ahead and take a look at it with you here. We are given a balanced equation that involves nitrogen dioxide, and it's converted into nitrogen monoxide. So we go from NO2 to NO, as well as molecular oxygen O2. We are given three graphs, and the labels on the x-axis is time in seconds, and the labels on the y-axis are concentration of NO2, 1 over the concentration of NO2, and the natural log of the concentration of NO2. And we are asked the following questions. A, explain how the graphs indicate that the reaction is second order. So we are not asking, the question is not asking you to determine if it's first order, second order, or zero order. It's actually telling you it's second order, but it says explain how the graphs indicate that, and then go ahead and write the rate law. So here we have the student answer, and then I will reveal the official answer in just a moment. The student says, because the graph is linear, using that order and the NO2 is squared in the rate law, and then they write R, or rate, equals K, the rate constant, times the concentration of NO2 to the second power. So think about how you might modify your response to get full credit for this question. Well, as you can see, they talked about a linear graph, but they did not identify specifically the graph of 1 over the concentration. So that was their mistake. They got the right rate law, but they didn't specify that the linear graph was 1 over concentration versus time. Just said the graph is linear, and they forgot to be specific. So again, be careful with your choice of words and try to be as precise as you can with your language. All right, we're going to stay in this question. We have some mechanisms here. Again, we know it's second order. It says consider the two possible mechanisms for the decomposition reaction. And we have step 1 of mechanism 1 involves two molecules of NO2 reacting together to produce NO and NO3, and that is a slow step. And then step 2, NO3, in a fast step, is converted to NO and O2. We also have a second mechanism in which we have a fast equilibrium for step 1 and a slow step for step 2. Each of these questions kind of asks the exact same thing. Explain how, or show, is the rate law consistent with the rate law? Is the rate law described by the mechanism consistent with this second order rate law that we've already established? All right, I can't put all of this on the same screen. So again, you can I can flip back and forth if you need to process this, but this is the two mechanisms. And now on the next slide, here's the student's answer. All right, they said yes for the first one. Yes, because the rate equals K times NO2 squared, which means that it is consistent. And then they said no, because the rate law described by mechanism 2 is rate equals K times concentration of N2O4, which is not the same. Okay, so they said yes for the first one, and they said no for the second one. All right, let me go ahead and pop the official scoring guidelines on the screen here. Now, they were correct in saying yes, but they were not specific. They did not mention the slow step of the mechanism or the rate law for the slow step. So their justification in part 1 was not sufficient. So they had to mention something about the slow or the rate determining step to get credit for their justification. And as far as part 2, they said no, and it's actually yes. They failed to realize that this fast equilibrium in the first step will lead to a conclusion that yes, this mechanism is consistent with a second order rate law. And again, you can see in the scoring guidelines that either because of rate or because of equilibrium constant, you can talk about how you can substitute the 2 molecules of NO2 for the 1 molecule of N2O4, and there's a mathematical substitution that you can do to show that the rate determining step, which is step 2, can actually be rewritten in terms of the NO2 molecules in step 1. All right, here is our next question. Again, I'm just trying to encourage you to be careful and thorough with your attention to details on this final virtual lesson in AP Chemistry. So again, I hope that these guidelines and little snippets of advice are helpful to you. All right, we have a new question, and we're focusing on the burette readings. Write down the initial and the final reading and use them to determine the volume. So I will show you the student's answer, which we already know is incorrect. And then you can take a look about what they did wrong and how you would answer this question. So here is the student's answer. They have an initial reading, which is the diagram that's on the left there, that large circle on the left. They said 4.63. And then their final reading, the large circle on the right, they said 30.43. And they got a difference of 25.8. So think about what you would have done and how you would have processed these diagrams. Well, if you know how to read a burette, you realize that you have to go from the bottom of the meniscus, but you also have to read them from top to bottom. So not 4.63, but somewhere between 3.3 and 3.4. So maybe 3.35, and then somewhere between 29.5 and 29.6, so possibly 29.55. And of course, the difference should include 2 decimal places. So the answer is not, as you can see on the box on the left side of the screen, it's not 26.2, which is what your calculator would give you, but rather 26.20 to show you're consistent with the precision of the burette being read to 2 decimal places and a volume reported with 2 decimal places. All right, so more practice questions to look at. I will tell you that I'm happy to give you the opportunity later to do this, and you can find these questions on the internet. Like I said before, just do an internet search for 2018 AP Chemistry Free Response, and you should find not only the free response questions themselves, as well as the scoring guidelines. These are publicly available. Okay, here's your next practice question with an example of a student mistake. All right, we are given a balanced chemical equation. At the top, you can see we have Na2S2O3 reacting with NaOCl and also reacting with NaOH, and the coefficients from left to right are 1, 4, and 2. A student performs an experiment to determine the value of enthalpy change for the oxidation reduction reaction represented by the balanced equation above. In the experiment, the student uses the solutions shown in the table below. And as you can see, we have 5.00 milliliters of a 0.500 molar solution for all 3 reactants. Using the balanced equation for the oxidation reduction reaction and the information in the table above, determine which reactant is the limiting reactant. Justify your answer. So again, there's that phrase again, justify your answer. So it has to be in terms of the information that you are given. Hopefully you're going to talk about the coefficients and the moles. Here is the student's answer. NaOCl is the limiting reactant because the reaction requires the most moles of this reactant to follow through. So think about what this student has done wrong and how you would phrase the answer to this question yourself. Well, the student did something right. They had the correct limiting reactant. But what they should have said is, given that equal numbers of moles of each reactant were present, again, that's from the table, it follows from the coefficients of the reactants that the NaOCl will be depleted first. So in terms of, there's 4 moles of NaOCl for every 2 moles of NaOH for every 1 mole of Na2S2O3. It's going to be the NaOCl that was going to run out first. So they did not mention the part about equal moles of reactant as given in the table. All right, here's our next question. We are given a graph. We're talking about solutions that are being mixed together, and there is a temperature change. This is a calorimetry experiment. The solutions, all originally at 20 degrees Celsius, are combined in an insulated calorimeter. The temperature of the reaction mixture is monitored as shown in the graph below. Now, the graph starts out at 20 degrees Celsius, and then it rises and plateaus somewhere between 32 and 33. According to the graph, what is the temperature change of the reaction mixture? And calculate the magnitude of heat energy in joules that is released during the reaction. Assume that the specific heat of the reaction mixture is 3.94 joules per gram degree Celsius, and that the absorbed heat, or heat absorbed by the calorimeter, is negligible. So we have a delta T and we have a Q equals MC delta T coming up. All right, here is the student's answer. They have a delta T of 12.5 degrees. Again, you can go back and look at that graph and see if 12.5 degrees makes sense to you for a delta T. And they use MC delta T. So the 15.21 is kind of hard to figure out where that number came from. We would have to go back and read that that's in the stem of the question, not any kind of table, okay? Just they say right there, 15.21, that's the mass of the reaction mixture. They were given the specific heat capacity of 3.94, and then what they did on the side, you can see that they converted the temperature from Celsius to Kelvin by adding 273. So their delta T is 285.5, and then they did the math. So think about what they did wrong and what they did right. Well, I like their delta T. I think 32.5 is a good estimate of the final temperature. So 32.5 minus 20 is 12.5. I'm not really sure why they converted Celsius to Kelvin. Maybe they were just programmed from doing that with ideal gas law calculations. But in this case, the change in temperature, if you were to do it in Kelvin, it would be adding 273 to the initial temperature and the final temperature. So you would have 305.5 minus 293, and you would still get a difference of 12.5. So it's their delta T that messed up their math. They were supposed to get 749 joules, and they got over 17,000 joules. Okay, so my message to you is to pay attention to units and be careful. All right, here we have a question focusing on the reaction at the top of the page and the delta H. You can, for this particular question, you can ignore the delta S and the delta T. That's not relevant to this question. All right, this says we have a reaction and the student hypothesizes that increasing the temperature will increase the amount of N2O3 in the equilibrium mixture. Indicate whether you agree or disagree, justify your answer. Again, so I'm trying to focus on the data, make a prediction, do you agree or disagree, and then justify your answer. This has to do with temperature and Le Chatelier's principle. Here's what the student said. They said, I agree with the student's hypothesis because the delta H is negative 40.4 kilojoules per mole, and that is an exothermic reaction. So heat is a product. Based on Le Chatelier's principle, when heat is added as a reactant, the reaction must shift to the right, so more product will be made and N2O3 will increase. So I like what they said about the exothermic part, but unfortunately they should have said disagree. Okay, so heat is not added as a reactant. That's the part that kind of messed them up. Exothermic means we have heat over here. And so if we add more heat by raising the temperature, then it's going to shift toward the left, not toward the right. So again, be careful with your answers to questions that deal with Le Chatelier's principle, and be careful with endothermic and exothermic. I don't want you to fall into the mistake that this particular student made on a question like this. All right, this has to do with atomic structure. We're given iron with a charge of +2 and iron with a charge of +3, and we're also given the ionic radii for these ions. The radii are given in the table above using principles of atomic structure. Explain why the radius of iron 2+ is larger than the radius of iron 3+. Here is what the student said. The radius of iron 2+ is greater than the radius of iron 3+ because the number of electrons in iron 2+ are greater. Each ion has the same effective nuclear charge, but iron 3+ electrons will feel a greater pull because there are fewer electrons to absorb the pull. Think about what that student said that was correct and incorrect, and how you would fix it, and how you would phrase an appropriate response to this question. All right, what they failed to mention is electron-electron repulsions. So they were correct in that both ions have the same nuclear charge, but this idea that there is a greater pull because there are fewer electrons is not at the heart of the question. So it's the fact that iron 2+ having an extra electron experiences in the outermost shell greater electron-electron repulsions. And so by not mentioning that, the student did not earn the point for this question. All right, here we have a new question involving a chemical reaction between iron 2+ and the permanganate ion, which is MnO4-. The student titrates a 10.0 milliliter sample of an iron 2 solution. Calculate the value of the concentration of the iron 2 ion in the solution if it takes 17.48 milliliters of added 0.0350 moles per liter potassium permanganate to reach the equivalence point. So this is again unit 4 about titrations. Here's what the student said. They have done volume, 17.48 milliliters, and they've multiplied by the molarity as a conversion factor. They have 0.0350 over 1,000 milliliters, and they got 6.118 times 10 to the negative 4. Now they don't have a unit, but that would be moles. They say at the equivalence point, the concentration of iron equals the concentration of permanganate. So therefore iron has a concentration of 0.0350. In other words, the same concentration as the permanganate. So think about what they did right, what they did wrong, how you would phrase an appropriate response to this question. Now, what they did right was they calculated the moles correctly. So 0.000612, or as they said, 6.118 times 10 to the negative 4, that part looks great. But the problem is they ignored the 5-to-1 mole ratio as given by the coefficients. So they somehow assume that moles of iron are equal to moles of permanganate, and without that conversion of moles of permanganate to moles of iron, without multiplying by 5, that's what they did wrong. Okay, so if you're given a balanced chemical equation, pay attention to the coefficients, especially when you are doing stoichiometry calculations. All right, here we have a simple calculation. Calculate the number of moles of iron in the Fe2O3. Now we are given 7.531 grams of Fe2O3. You can kind of ignore for this problem the mass of the iron with an inert impurity and just focus on this. Calculate the number of moles of iron in the Fe2O3. Okay, let's take a look at the student's answer. Think about what they did right and what is incomplete or incorrect about their answer, and how you would construct an appropriate response to this question. So as I say many times, you'll hear this over and over again from me in my videos. Read the question carefully. Make sure you are answering the question that is being asked. So they definitely converted moles correctly, but then they stopped. Instead of getting moles of iron, they stopped at moles of Fe2O3. And so without multiplying by 2, the numerical answer is incorrect. So read the question carefully is my advice to you. All right, here we have a new problem. It says a 10.0 gram sample of CS2, carbon disulfide liquid, is put in an evacuated 5.0 liter rigid container. The container is sealed and heated to 325 Kelvin, at which temperature all of the CS2 liquid has vaporized. What is the pressure in the container? Sounds like the ideal gas law. Here's what the student did. PV equals nRT. They have P for pressure, which they're trying to solve. They have 5 liters. They have converted 10 grams of CS2 into moles. So think about if that looks correct. They have 8.314 joules per mole Kelvin. They got that number for R off of the equations and constant sheet. And then they have 325 Kelvin, which was given in the problem. So they calculated the moles, did the math, and got 70.99 atmospheres. Think about what they did right, what they did wrong or is incomplete, and how you would construct an appropriate response to this question to get the correct answer. All right, well, it has to do with the rate. I'm sorry, not the rate, sorry, the ideal gas constant. It has to do with the ideal gas constant. So the ideal gas constant on the equation sheet, sometimes this value is used, especially with thermodynamics and certain calculations involving R. But if you're trying to solve for pressure either in atmospheres or in torr, then you would want to choose the value of R that is consistent with those units of pressure. So they used the wrong version of R because their answer is expressed with units of atmospheres. So again, my advice to you is to pay attention carefully to units throughout your calculations. All right, here we have a rate constant question. A radioactive isotope of the element, a particular element, doesn't matter which one, decays with a half-life of 10 minutes. Calculate the value of the rate constant K for the radioactive decay. Include units in your answer. So the student has written down that the half-life is 10 minutes or 600 seconds. They have found an equation for half-life, which is for a first-order rate constant, first-order decay, which is what radioactive decay is always first order. 0.693 divided by K equals the half-life. They plugged in 600 seconds equals 0.693 divided by K, did the math, and got 1.2 times 10 to the negative 3. So think about if they answered the question correctly, and if not, what they did wrong. All right, and the official scoring guidelines say the following. Now, don't worry about the minutes versus seconds. They could have easily done 0.693 divided by 600 seconds, and I'm fairly confident that the math is correct. But as you can see, if you read carefully, include units with your answer is specifically stated in the stem of the question, and they have left off their units. So it should be either inverse seconds or inverse minutes, depending on which unit of time you plugged in to that first order half-life equation. So they would have gotten credit for the numerical answer, but they would have lost the point for the unit. All right, here's our next example. This will be our last example, and then I'm going to go into some general advice and guidelines for constructing good FRQ responses on the AP chemistry exam. We have 64 atoms of a radioactive isotope. And how long does it take, if the half-life is 10 minutes, to go until you have 1 atom of the isotope? So the student has gone from 64 to 32 to 16 to 8 to 4 to 2. To 1, sorry, all the way. 64 to 32 to 16 to 8 to 4 to 2 to 1. And they wrote down 5 times 10 equals 50 minutes. So their answer is 50. It's kind of an obvious mistake that they did wrong. If you do the careful counting of the arrows and the fact that there's 10 minutes for each half-life, we have 1, 2, 3, 4, 5, 6 half-life periods. So again, they might have just been rushing and going too fast and were not careful. So what they got right was the setup. What they got wrong was the total time. It should be 60 minutes and not 50. And there was another way they could have solved it using the first order integrated rate law, because again, radioactive decay is first order. Okay, so again, here's some general suggestions and guidelines for answering FRQs. Here we go. Read the question carefully, as I said, and make sure that you answer the question that is being asked. If you do a calculation, show your work. Do not just show the final answer, show your work in some form. Now, you don't have to show units in your calculations. However, it is a good idea to pay attention to units, both in the numbers that you are given and throughout the steps in your calculations. That way you don't switch from grams to kilograms or kilojoules to joules or liters to milliliters and not remember what you had started with. If you are given a balanced chemical equation, make sure that you use the mole ratio from the coefficients in your stoichiometry calculations. And again, even though I want you to focus on time and be aware of time, don't rush so much that you avoid, that you make a careless error. So double check your math to avoid careless errors. A question may ask you to make a choice and then justify your answer. State your choice before you start writing. Some students go into all these wonderful sentences about why they agree or disagree, but then they never actually said, I agree. So we don't know what choice they made. So state your choice and then go into your justification. With intermolecular forces, if you are asked to list all of the IMFs for each substance, make sure to include all of the IMFs for each substance. So if it's London dispersion forces and that's it, okay. If it's a polar molecule, say LDFs and dipole-dipole forces. If there's hydrogen bonding, say LDFs, dipole-dipole forces, and hydrogen bonding, so be complete. Suppose you're talking about atomic structure and you're asked to compare two different elements or ions. Make sure to write about the specific details of the atomic structure, such as protons, electrons, orbitals, energy levels, repulsion, Coulomb's law, etc. A periodic trend, such as atomic radius decreases from left to right across a period, is not a justification. So do not say size gets larger as you go down. That is not your reason why. Talk about the orbitals and the energy levels. Don't say size gets smaller as you go across. Talk about the difference in effective nuclear charge and how the valence electrons are located in the same shell or energy level. Now, if the question says, justify your answer in terms of a particular something, make sure that your justification mentions that particular detail because they are looking for that in your answer. Okay, so again, that goes back to read the question carefully. If you are asked to explain an experimental observation, talk about the chemistry that gets to the why. Do not simply restate the facts or give a definition of a vocabulary term. For example, magnesium has a higher first ionization energy than sodium. If your answer is because it requires more energy to remove an electron, you haven't explained why. You've simply talked about what ionization energy is. Or if it's a boiling point thing, don't say it takes more energy to go from a liquid to a gas. Talk about the why, talk about the relative strength of the intermolecular forces. Or in this case, talk about the magnesium having one more proton than sodium. Now, if they want the bond angle, then give a number. Give the bond angle. If they want the molecular shape, then give the name of the shape. If they want the hybridization, sp, sp2, sp3. So don't confuse these terms. The bond angle is not tetrahedral. The molecular shape is not sp3. So be careful to be clear with your choices of words and terms. As you already know from studying chemistry, Coulomb's law can be useful when discussing things like lattice energy, comparing two ionic compounds, the strength of attraction between ions and something polar like water, intermolecular forces, covalent bonds, single versus double versus triple, or about periodic trends in terms of the attraction between the nucleus and the outer shell or the electrons, or a PES diagram. Do not confuse a covalent bond within a molecule with an intermolecular attractive force between molecules. When using the ideal gas law, convert Celsius to Kelvin, pay attention to the units of R, and don't use 22.4 liters per mole unless you are at STP. Some students use that number for any ideal gas law problem, and that's incorrect. All right, with respect to reactions, if you have to write a net ionic equation, you don't need to write the phases of matter, but you should make sure that your equation is balanced in terms of both atoms and charge. Okay, like here's an example. Okay, so if I have, let's say, aluminum plus copper, and then my products are the aluminum ion and copper like that. That's balanced in terms of atoms, but it is not balanced in terms of charge until I do something like this. Okay, so pay attention to both atoms and charge. With respect to different types of chemical reactions, there are three. We have acid-base reactions in which a H+ or a proton is transferred from an acid to a base. We have precipitation reactions in which a sparingly soluble substance is produced as a precipitate. Remember that the soluble ions include sodium, potassium, ammonium, and nitrate. Oxidation, reduction, or redox. If an element loses electrons and the oxidation number increases, then that is being oxidized. If an element gains electrons and the oxidation number goes down, then that is reduction. Remember which order goes with which integrated rate law. So we have 0, first, and second, and that the half-life equation is for first order. If the half-life is constant, then it must be first order, and vice versa. If it's first order, then the half-life must be constant. I mentioned this earlier. If you are given a table with standard enthalpies of formation, you can go products minus reactants. But if you are given a table with bond enthalpies, it's bonds broken minus bonds formed. If you mix chemicals together and a reaction occurs and the temperature increases, it's exothermic. If the temperature decreases, it's endothermic. That's when the temperature change happens all by itself, not with a hot plate or a Bunsen burner. Just the temperature just rises on its own or falls all by itself. Remember that Q and delta H are not the same thing. Q is the amount of heat that is either absorbed or released, whereas delta H is the change in enthalpy for a process. And delta H is normally the Q divided by the moles of the limiting reactant, and is sometimes expressed as kilojoules per mole of reaction. So again, pay attention to your coefficients and your moles and things like limiting reactants. Your delta H should have a sign, either positive for endothermic or negative for exothermic. If you're doing a calorimetry calculation involving MC delta T and you have a solution, then the M is not just the mass of the solute or the solvent, but rather the mass of the entire solution. That is a common mistake that students will make. And normally the specific heat capacity is for the entire solution that's given in the problem. If you are given a value of equilibrium constant, K, and it's very large, you can assume that the reaction essentially goes to completion. So you have lots of products and not much reactants. If the value of K is very small, you can assume that the reaction barely proceeds. You have lots of reactants and not much products. Sometimes making a rice table can be a good strategy when you are given the initial conditions and you are asked about what happens when equilibrium is reached. If Q is less than K, then you're going to shift toward the products. And if Q is greater than K, then the shift is toward the reactants. All right, I do have one final kind of send-off video to show you, which is kind of a little montage of different AP teachers on these live programs. I really want to thank you all for watching all of these AP chemistry videos. Here's a reminder to go to cb.org/AP2020. Get ready to do your 5 steps to get ready for the AP exams. And now, enjoy this little video montage. If I can get it to play. All right, I'm just going to pause because I don't know if I have shared my audio. I'm not sure if you guys are getting this. So give me a moment to double check that I have shared appropriately here. So I am going to do a share and make sure that music, computer sound only. Here we go. Okay. And now, let's see if I can do this here. All right, looking for the play button here. There we go. Oh, I'm getting message that it's still not working. All right, I'll try one more time here. So I need to do a share in such a way that I can get my computer sound. Oh, that's just computer sound. Ah, that's what I have to do. Okay. I'll try this one more time. I see where it is. Share computer sound. That's what it is. Okay. Here we go.
We are live.
So we're going to walk you through everything you need to know and you're going to have it. And so, may the 4th be with you.
Continuiamo anche il nostro giro per l'Italia.
You Are a Local Lunatic shared this via Twitter. I'm really, really grateful for @JacobsPhysics and @Mr. JB Physics and just @College Board in general for doing so much for these AP exam reviews. I actually get stuff a lot more than I did before COVID happened, and I'm just really, really grateful for that. Smiley face.
All right, so we're talking about the overall big picture of period 4. Here are some things I just want you guys to remember.
KOA shared on TikTok, AP English Zoom streams are my only social interaction right now. #FYP, #isolation, #AP English.
They would send large ships of laborers just to collect the guano and get on the ship. Is collect the right word? Do you mine guano? Do you excavate it? I don't know what the verb is there. I'm supposed to be using.
And we're going to be focusing on tone. Specifically, how do you read and interpret tone?
Karen Tabola Moore on Facebook shared, my students have enjoyed the AP Latin videos with Jeannie Luangu. Since I can only give a live Zoom class twice a week, this has been a great support.
Or I could say I want my lawyer and they have to get me my representation. But, and here's our but for today, that is going to sacrifice the abilities of the community.
Am I sharing the slideshow right now, by the way?
Nope. If you are, I can't see it.
Utkarsh Kali shared on Twitter, thank you for the helpful AP classes on YouTube. My preparation for AP Calc VC has become so much easier and efficient.
So I drew this like 4 o'clock this morning. So it's not beautiful, but I think it gets the point.
You turn over another card and they get compared and that person would win. Tell me if you do it differently, Mr. Schultz.
The more that you can find that connection within yourself, within the character, I feel like you write the character with a lot more depth.
Learning about the economy is important, and I wish more people did what you're doing.
My advice to all the students out there, whatever it is you choose to go into, make sure that it's a passion that burns in your belly.
I learned so much working in local government about public service. It teaches you that it's 24/7 and that you have to learn to listen.
I am someone who believes in following your passion, right? And working hard. And if you kind of find that there's something out there that you think is a need in the market and no one else is making it, then maybe you have to be a little bit creative.
11th grade US history is the reason we're talking, because I don't think I would have picked up Ron Chernow's biography of Alexander Hamilton if I hadn't written a paper on Alexander Hamilton in high school.
Asia K3 shared on Instagram, I'm so glad he came. He's the reason I was able to get more interested in US history, and I always listen to the Hamilton soundtrack when studying for English. Emoji.
We have a message here from Girleen from Instagram. She says, definitely worth waking up before noon.
And so you just connect your battery to your magnet like this, and then you get copper. Ta-da!
Look at that. That's amazing.
When are we ever going to need calculus? You'd be surprised. I mean, you might make videos and then calculate like the breaking pressure of Thanos' abdomen if Ant-Man were inside it.
This one hit close to home. This is very special for me. Mr. Walters teaches in Managua, Nicaragua, and that's where I was born. And I want to say hello to all the students out there.
Lyra Matt tweeted, I watch every AP Lit video. They're so helpful, especially for students whose first language is not English. Ms. Barber and Mr. Carler's enthusiasm and passion inspired and encouraged me not to give up.
Miren, Julia de Burgos nace, es todo un mito en la littérature caribeña.
Pour souligner encore ce qu'on essaie de faire, on veut expliquer des idées et des opinions.
Mrs. Lowe shared on Twitter, these videos are excellent. They do a great job of reviewing mixed material with an awesome job of presenting new material.
好，下面是 cultural presentation。抱歉让大家坐着哈，但是这个很重要。
今日も一緒に日本語を頑張って勉強しましょうよ。はい、それで。
Chanel Kernander said on Twitter, love Mr. Escobar and Miss Barber's videos for my AP Lit students. You two are awesome. Tuning in live from Houston, Texas.
What'd you say for Dabo? Did you answer what that means?
Yeah, future. I will give.
Just as Gandalf parted ways with the hobbits before they undertook the scouring of the Shire, the time is almost here for Josh and me to sail into the West.
Thanks for showing up every day and reviewing the course with us. And remember, on the exam, sound like you've taken the course. Be specific and be scientific.
It's been a blast working with you all spring. And like I said, this chapter of your life isn't over. You now have a chance to rewrite.
Thank you so much for watching Mark and me for these last 30, I don't know, however many sessions we had. And if it weren't for you, we wouldn't have had these sessions.
Well, thanks for watching. And one final piece of advice. If the question seems really complicated, it's probably not.
Gracias por haberme acompañado durante estas semanas.
I just want to say thank you to all the amazing AP Statistics students out there that have been following along with us for the past 6 weeks.
Thank you so much for watching. We really appreciate it and hope these videos have helped.
Hearing from you and seeing the pictures that you've sent us of your pets, thank you so much for tuning in.
Thank you to everyone for watching, for tuning in, for continuing your educations. Best of luck on your exams.
You've prepared, you're ready, do your best on this exam, and then congratulate yourself no matter what you get.
Optimum Fortunam Omnibus. Best of luck to everyone.
Thank you for tuning in to all of our AP Bio review lessons and our practice exam.
Bon courage, as we say en français.
Thank you so much for tuning in. Luke and I really had a super fun time, and we hope you learned a lot.
Thank you to all of the AP Chemistry students who watched the videos.
You're good enough, you're smart enough, and gosh darn it, people like you.
Thanks for tuning into all these videos. Music theory friends, don't forget to resolve your tendency tones.
You guys have got this. Remember, you are the solution.
Thank you so much for joining me the past month and a half. It's been such a journey and such a treat for me.
Hey, thanks for watching the last 6 weeks, especially the calculus crew.
You guys are awesome. You are excellent. You are brilliant. I really, really enjoyed our time together, and I know you guys are going to rock that exam next week.
Just remember that you have worked your butts off this year. Y'all are going to do great.
It is time for you to shine.
Type your response, copy it, paste it in the submission box. Good luck.
Arigato. Thank you. Ganbatte kudasai. Remember to practice on the app that comes out next week.
Y'all are going to do great. And remember, geography is everywhere.
All right, well, that is the end of our lesson for today. Here are the important links. Have a good day. Good luck on your AP Chemistry exam. Thanks for watching.